Welcome everyone to another episode of the Practical SQL Server HA show. My name is Edwin Sarmiento. I'm a Microsoft Certified Master for SQL Server, and I specialize in high availability and disaster recovery solutions. This is actually the last part of the three-part series. I started talking about this in the beginning of the year, where I want to go back to the basics, and the reason for that is, again, there's nothing wrong. No, you can't go wrong with going back to the basics. But the idea behind this is to take a look at the things that we technical professionals don't pay attention to when it comes to building, implementing, and managing high availability and disaster recovery solutions. If this is the first time you're joining in, welcome. If you've been following along for quite some time now, welcome back. The topics that I cover in these episodes, I call them episodes, but the topics that I cover in these episodes revolve around tips, tricks, and hacks on how you can successfully implement, manage, troubleshoot high availability and disaster recovery solutions. But rather than just focus on the technical aspects, which most technical professionals like us already pay attention to, I focus on the human and the process aspect of this because, for one, again, that's something that we don't pay attention to. In fact, the people and the process aspects are the ones that actually make or break a high availability and disaster recovery solution, right? Um, Again, this is the last part of a three-part series, and I decided I want to break it down into multiple parts because I wanted to really dive into what it takes to look into some of the things that we don't consider. I call this the SMH, the who and what of HADR. If you haven't seen the previous two episodes, watch them. They're recorded. They're out there. YouTube, LinkedIn, my Facebook page. They're all out there. But just to give you a preview, okay? SMH. What is this? Every letter of SMH stand for something, and I kind of use the acronym SMH because when I get brought into a customer environment and we're either implementing a new solution or troubleshooting a problem or addressing an outage or trying to anything HA and DR, I kind of shake my head when they bring something like this and thinking, why are they not even considering these things? Okay, so putting back my slide deck here. Uh, if you haven't watched the first two episodes, I highly recommend that you do. But just to give you kind of like a 30,000-foot view of what these are, S stands for the other storage. And I'm not just talking about disk. I'm talking about stuff like runbook documentation, processes, other drivers or firmware that you need, and you being somebody who's been working on the environment, the infrastructure within the team that has institutional knowledge that you've gathered throughout the years, you got to make sure that that's well documented because, well, even if you want to retire in that job and you're just happy, there's no guarantee that you're going to be there tomorrow. There is no guarantee. And so, in order for the work to be something that somebody could take on and run with, you got to have documentation for that. And again, I emphasize the fact that we don't, as technical professionals, don't like writing documentation. We need to be, right? So that's the S. And then M stands for the other manpower. And I'm not just talking about you, the DBA, taking care of the databases, other manpower. I talked about your service provider, if you're hosting your infrastructure or your solutions on a co-location facility or a public cloud vendor, or you're renting a data center space, your service provider for your network service, like if you're building a DR solution and your production data center is connected to your DR data center, how are they connected? You have a service provider for that. Your uh, hardware vendor, your boss, uh, all of these people that are outside of your team that you're not aware are part of your HA and DR team. Okay. Now we dive into H, and this is quite short because again, there's just way too many things to consider. But hardware, H stands for that other hardware that we don't think about as technical professionals. And this is something that I learned working as a data center engineer a couple of years back then. Because again, as technical professionals, the hardware that we think about are network switches or network equipment, hardware, servers, what else? And outside of that, it is very difficult for us to see what else or what other things we need to consider because, again, this is something that we do day to day, something else come up. And because we don't have any background, in my case, the reason I'm sharing all of these is because when I was starting out, I did not know because I was so fixated on the tech that I knew, on the hardware that I knew. So it's hardware for servers, network equipment, switches, PDUs, racks, all of these things, but not considering these other hardware. Grab your pen and paper ready. Take notes. Okay. What other hardware? Ironic when I say your heating, your ventilation, and air conditioning. I didn't say ironic because I never thought of this, despite the fact I spent 2.5, no, 3 semesters in my undergrad. I have a mechanical engineering degree, and I spent about 3 semesters learning about heating, ventilation, and air conditioning. But when I started working as a tech professional, working as a data center engineer, as if this thing disappeared, as if they never existed. One of the reasons I, it's just me. One of the reasons I wanted to work in tech is because my idea was I would be sitting in a room with air conditioning. I come from a third world country, tropical country where it's humid, it's hot. So it would be great for me to be working in an office with air conditioning. Oh, by the way, not to mention that I will be going in and out of a data center that's probably around freezing temperatures or slightly above freezing temperatures, and I'm okay with that. But then I forgot that HVAC, heating, ventilation, and air conditioning, is something that could impact high availability and disaster recovery. A couple of years back, we had an alert, and this was a weekend where we typically do our scheduled maintenance. We would submit a request for change management request, and weekends are typically our maintenance window. Depending on the approved maintenance window, we take advantage of the weekend. Plus, not a lot of business activity over the weekend. So we were doing maintenance. And all of a sudden, as I was going through maintenance, I see an alert in our monitoring tool. I get an email alert, high CPU. Wait a second, what's going on? All I knew at that time was we were doing maintenance. There were no active production workload. And if there were jobs, background jobs that are happening, these are typical jobs like regular maintenance, backups, nothing that would cause the CPU to spike. So I was doing my typical investigation, looking at performance counters, looking at task manager, looking at some of the tools. We're still seeing CPU spikes. And I'm like, what is going on here? Right? Processes are the same. A CPU spike still at 98, 99%. And I was, of course, it's maintenance window, restart the services, all good, reboot the services, all good. But then, performance will return to normal. Again, I'm not recommending that you reboot the servers just because, but this is our maintenance window and it's okay. We're performing maintenance. The minute that we reboot the servers, the CPU would spike up from 10, 20, 30, all of a sudden 99%. What is going on? I just rebooted the server. Then we got a phone call from somebody at the data center telling us 3 of our air conditioning systems are busted. Couldn't turn them on. And the data center is so hot, literally so hot. And it's the first time, again, ironic because I have a mechanical engineering degree and I spent 3.5 semesters trying to learn HVAC. This was the first time that I recognized that air conditioning can really impact your DR solution or your HA solution. One of the reasons why, even after rebooting the server, we still had a spike in the CPU was because the server is now experiencing extreme temperatures. You know how it is? You have your fans in your servers. Of course, the assumption is you see in a server, but nowadays we barely touch servers. Everything's virtualized, so no, we don't see. Your CPUs get so hot, and it's one of the reasons why they have to be maintained in an air-conditioned room with really good temperature managed properly. Your CPUs are hot, and that's also one of the reasons why you're putting in fans with good ventilation and all of these things. But now that the air conditioning isn't working, imagine how it is. Because I used to work with, I used to have an AMD based CPU, or I would have like any kind of approach to dissipate the heat. But the thing is, because the air conditionings were not functioning at that point, the CPUs and the servers are starting to get hot, which affects the performance. So it has nothing to do with workload. It has everything to do with the temperature of the CPUs of the servers because there's no air conditioning. So what we had to do, we were instructed to power down all non-production servers. So we were shutting down UAT and staging environments. All we kept was the production environment. The data center engineer had to bring in an industrial fan, open up the windows at the data center, and he started blasting the industrial fan just to keep the servers up and running. They started calling HVAC technicians to fix the air conditioning, but that was the first time that I became aware of the fact that stuff like this happen, right? Stuff like this happen, and they affect HA because at that point we can't power on all of our servers, which means our ability to achieve high availability and in that case potentially disaster recovery, we couldn't. Even though we built clusters that would provide HA, but we can't power on all of the servers for that purpose. So we don't have a choice. They power down the servers. And again, this is something we don't think about when we're planning our HA and DR solutions. That other hardware includes your HVAC systems. And even with the design, and I didn't include it here, even with the design of how the data center is set up, how servers are racked and stacked. And again, in today's data center and both public and private cloud, we don't even think about these anymore because we cannot physically touch servers, right? They're somewhere out there, and all we see is a VM. And then when CPU spikes, we don't even know, is that the virtual CPU, is that the physical CPU, and if it is the physical CPU, what's going on in the data center? I remember this was a couple of years back uh, when one of my clients had a data center that's below ground level. It's underground, thinking, oh, it's relatively cold, until the underground data center got flooded because a pipe was busted. Stuff like this. We don't recognize these, but then they happen. And that's one of the reasons why these are things that we don't consider. Yet they impact and they affect your high availability and disaster recovery solution. So yes, heating, ventilation, and air conditioning, that was the very first time that I realized I'm not supposed to be thinking about this because that's not my job. That's supposed to be the air conditioning technician's job. But they come in not thinking, oh, we need high availability for these systems. They don't. All they knew is that, well, it's centralized air conditioning. We're providing you with these, but whatever happens, it's okay. And so when you start looking at, it's fascinating because when you start looking at these data centers from the large tech companies, like there was a video on, I think it was on YouTube, about Facebook's data centers where they have redundant air conditioning in case something goes wrong. They have redundancy so that a backup air conditioning system would kick in, and not just the air conditioning system, power supply. Yes. Again, this is something that we don't think about because as technical professionals, rarely, again, in today's world of private and public cloud or even co-location, you barely get to touch these. And so think about this. Let's say you're working for a company that's small, medium size. You have a room, a small sized room, the size of your data center, and the company's growing. You have multiple racks within the data center, and all of a sudden, hey, we need additional servers. So of course, additional servers mean additional heat generated from those servers. Not only that, additional power consumption. Have your engineers or your electrical engineers, have they designed the power supply to be able to take in additional load? And again, it's difficult to forecast this because we don't know. It's one of the reasons why the public cloud became a thing, because we don't know how to forecast these things. Maybe we grow within a span of a year, or maybe we grow too fast, we grow in a span of a week. But can we accommodate that growth that fast, right? Power distribution units, for instance, maybe one rack can accommodate 3 or 4 switches plus 3 or 4 servers in one rack, and you have one PDU or power distribution unit. The question is, what happens if you add another server and another switch that you need to plug into the power distribution unit? How is the power distribution unit capable of handling that additional workload? What happens if it couldn't? Will it take down the entire rack? Will it take down the circuit breaker? All of these things, we don't think about this. I did not think about this. You know how it is? I only got I got I was only made aware of this when I remember those times when you have uninterrupted power supplies and you think, oh, everything's protected because I have a UPS, and when we have a power outage, everything's protected. Yes and no, because your uninterrupted power supply also has a rating. How much power can you draw from the UPS without taking it down? There's wattage, there's voltage regulation, and all of these things that you have to consider. And we had a power outage, the UPS working fine, but then and I'm not even talking about servers and data centers here. I'm talking about me personally using it. I had to print something, plugged the printer in the moment, and printers don't consume a lot of electricity or power. Plugged it in, turned it on. The minute that it started printing, it just so happened that it triggered the maximum capacity of the UPS. But that's the thing. We don't think about a heating, ventilation, and air conditioning. We don't think about power supply, power distribution units, or the capacity of your power supply to address whatever power demands of your existing system. Again, we look at it as, especially, let's walk through how you would implement an HADR solution. Yep, these are the servers that we need. These are the components that we need. This is the project. Sure, rack and stack the server. Oh, by the way, we need storage area network. Sure, put it there, plug it in, rack and stack, connect, and everything. Powered on, everything's working fine. So for the longest time, you have this way of thinking that, hey, power can handle it. We just added additional servers and the storage area network. Everything's working fine. Until you had to add another server or another switch that you need to plug into the power distribution unit, and next thing you know, it takes everything down. The worst part of that is, especially with a rack, servers in a rack, you plug your servers in a power distribution unit, which acts as a redundant power supply. Even you plug one server, takes everything with it, and triggers the backup, but then the backup could not handle it because they're the same rating. Backup kicked in, could not handle it. Next thing you know, the redundancy didn't provide redundant. And again, this is something that we cannot predict because we don't know when we are going to be needing a new server, a new switch, a new router, a new equipment within the data center. So even the power supply is something we don't think about, right? Again, these are hardware that we may or may not think about. And it's very difficult to plan for all of these things, especially if you've not encountered it before. I remember when we were testing out our DR plan, back then working as a data center engineer, part of the compliance requirement that we need to meet is we have to test our DR plan every quarter, which means we really have to make sure that we're at the top of our game every quarter. And so we were happy about the fact that we were automating a lot of these stuff. We would run scripts, test the DR, and we were sitting back and thinking all of these things until the network engineer started bringing up the question, well, wait a second, everything works fine. But we did not test our network switches. What does he mean? Unplugging, making sure that we're inducing issues to really test DR. And that's when we started thinking about that hardware. Again, in a real disaster, worst case scenario, you got to plan for the worst case scenario. But it is very difficult until you're now in that situation where you didn't plan for that situation. Again, it's impossible. I'm saying it is impossible. You only plan for the worst that you assume would be your worst. Okay, and of course, we don't have deep pockets. Budgets are constraints. Resources, manpower are constraints, and so we can't really do everything. But we do the best that we can, given the limited amount of resources that we have, by managing those risks. Right, by managing those risks, and we're not even thinking about natural disasters. It's the ones that you do not think about. This got me thinking because uh, I spent a couple of months in San Francisco helping out my dad. And as I was working on something, I felt the house shake. Felt the house shake. And so when you start to think about that, that's a natural disaster that people in California encounter. So they designed their data center, racks are bolted to the floor, to the ceiling, so that when something like that happens, servers are not going to fall off. Right? They're securely fastened in such a way as to protect those digital assets, networks, servers, everything, from a natural disaster like that. But they plan for it. But I'm pretty sure the first time they've encountered something like that, they haven't thought of it. It's a natural disaster that we never thought were about to happen. Growing up, being born and raised in the Philippines, we encountered a ton of natural disasters, but nobody ever predicted the largest volcanic eruption in our history for 100 plus years that forced the United States naval and air force base to evacuate the country. That's how massive it was. But nobody planned for that. Nobody anticipated it because we've never had that experience before. And so it's the things that we don't think about, the natural disasters that we have not experienced yet. But of course, in countries like Japan, where earthquakes are a thing, they plan for that. The buildings, everything, they planned for this. Even in the state of California, they plan for this. They have stuff in place. But if you're right in the somewhere where you don't encounter any of these and all of a sudden they happen to you, at the back of your mind, you don't think about it because you've never experienced it before. State of Louisiana, they know hurricanes, come every year. They kind of plan for it. State of Florida. And so they have these. But again, if you're in a state or in a city where you've never had anything like that for the past 100 years, how do you plan for it? How do you anticipate something like that when you've never had any experience? And so even if, right, it's the ones that you do not think about. It's considering the things that you've not experienced yet you're already planning for it. There's just so much that you can plan for. And that's, again, one of the reasons why the idea behind public cloud infrastructures became a thing. Well, I can't plan for everything. If I fail over my local data center to Azure or AWS, and AWS is running a data center somewhere, I don't have to worry about it, because what are the chances that an earthquake would cut the United States in half? I don't know. Never happened before, so probably it's not going to happen. But again, it's one of the reasons why public cloud infrastructures like these have taken off. It's because we do not know what's going to happen, the unpredictable, right? And so these are the risks. So this sums up the three-part series of let me go back to my slide deck. The SMH, right? I call them SMH, uh, the who and the what of HADR. These are the things that we don't consider when we are implementing, we're planning, we're managing high availability and disaster recovery solutions, but directly impact your solution. And this, it's not just for SQL Server, it's for everything. I didn't talk about SQL Server throughout these three-part series, but they impact SQL Server, right? It impacts all of these things, impact the way you implement, you manage, you troubleshoot, you address issues with your high availability and disaster recovery solutions. S for that other storage, M for that other manpower, and H for that other hardware that have nothing to do with tech, right? That is about it for this, and this wraps up the three-part series of the SMH, the who and what of HADR. Again, I would highly recommend that you go back to the first two episodes so you can have a kind of like an idea of some of the things and start asking a question: what else have I not considered? What kind of storage have I not considered? Go back, look at the recordings from the past episodes. They're there somewhere. But it's on my YouTube channel. Tune in again next week for another episode of the Practical SQL Server HADR show. And if you need help with either implementing, designing, architecting, or even having your engineers be prepared for the kind of HADR solution that you're implementing. Most of the time, customers would reach out to me when it comes to not just implementing, managing, and deploying, designing always on availability groups, failover clustered instances, but also getting their staff ready, because I always tell people you need available and capable staff in order to manage your high availability and disaster recovery solutions. Reach out. If there's something I can do to help, I'm more than happy to do so. Use that link on the screen, schedule a strategy session, and let's have that talk. In the strategy session, we'll look at either your existing environment, if you have one, or if you don't have one, you're planning or you're thinking about implementing a high availability or disaster recovery solution. We're going to look at what your goals are. And then in the process, we'll come up with a strategy on how to achieve those goals, right? Use that link on the screen, schedule a strategy session. Let's have that talk, all right? Enjoy the rest of your week. I'll see you again in the next episode of the Practical SQL Server HADR show.